So, good day, everyone. We are the group 5, and our topic for today is planning and execution of blind pilotage and Anchorage. So, first is the members. We have Noinay Ivan Roland, Antiveros Van Philip, Pamal Jindeo, Paninsaro John Lloyd, Paredes McGreg Kenneth, and Pasatiempo John. So, for the intended learning outcome, so at the end of the session, the students should be able to first is understand the principles of blind pilotage and anchorage. Second is understand the responsibilities of a blind pilotage officer. Third is plan or how to plan a blind pilotage. And last one is how to execute a blind pilotage. So for the abstract, so blind pilotage means the navigation of the ship through restricted waters in low visibility with little or no recourse to the visual observation of objects outside the ship. So, um, this is a principal non-visual aid to navigation, which enables in high definition warning surface radar, but all available non-visual aids are employed. So the organization to achieve this is called the Blind Pilotage Organization, comprising a blind pilotage team led by a blind pilotage officer. So let's talk about first the introduction of the topic. So we're going to talk about the assessment, parallel index techniques, radar clearing ranges, course alterations, responsibilities, conduct of blind pilotage, and blind pilotage team and duties. So after that, we're going to discuss all about the planning and execution of blind pilotage, which covers the principles, planning, execution, the blind anchorages, navigational records, and horizontal displays. So let's talk about the assessment of the risk involved in a blind pilotage passage. Although normally the accuracy of blind pilotage is such that a ship can be taken to an open anchorage and anchored within 50 yards of the desired place, so the degree of the risk involved, particularly in restricted waters, must be carefully assessed. So the congestion due to the shipping, so failure of radar or other vital aids. Once the ship has been committed to her passage, then the number and quality of fixing marks must be taken into account. So the next one is PAL index technique. So this technique is the key to blind pilotage. So the running of a PAL index line provides real-time information on the ship's lateral position relative to the planned track. So on the chart here on the figure 1, as you can see on the right side, a line is drawn from the edge of a radar, like this one. And is drawn from the edge of a radar conspicuous object, like this. See, this is the object 1, 2, 3, 4, 5 as as the ship is moving. So parallel to the planned track. So the perpendicular distance or cross index range from the object to the track is then measured. Okay? So the range strobe on the radar is then to set the range, and a solid China graph line drawn on the display parallel to the planned course on a scale appropriate to the range used. So positions 1, 2, and 3 on the chart and radar display show the ship on the track at various instances up to the time. So this is not the number of targets, but it is the it is only one target, but it is moving due to the time constraint. So at various this is that up to the time that the island is abeam to the starboard. So positions 4 and 5 shows the ship off the track to port. The exact distance off track can be measured by dividers from the radar echo of the island to the nearest point of China Graph Index line at the scale of display. So this can be made easier by constructing scales for each range setting as shown below and mounting them adjacent to the display. So the crosses on the chart do not represent fixes and only appear in order to illustrate the example. So the next one is radar clear changes. So as you can see, this is the radar clearing changes in a figure 2. So are similarly drawn to the maximum or minimum distances from the radar conspicuous objects to keep the ship clear of dangers. These are drawn as broken lines. The next one is course alteration.
So for the next topic, so we're gonna talk about the course alteration. Next slide, please. So course alteration. Willover positions are calculated and plotted on the chart as for visual pilotage. A rather conspicuous mark selected as close as possible to the willover position. A peaked line, you can see, that broken line is then drawn through the willover position. So we can see that on the next slide in the figure 2, and a parallel to the new course and the cross index range measured. This willover range is plotted on the display as a peaked line, parallel to the new course. When the selected mark reaches this line, the wheel should be put over and the ship brought round to the new course, by which time the mark should be on the firm line denoting the parallel index for the new course. So this is the illustration that I have been talking earlier. So this is the figure 2, which is the clearing and wheel over ranges on the chart and the radar display, which the wheel over range represents those broken lines as you can see in the illustration. So next slide, please. The next is the responsibilities. So responsibilities. In normal circumstances, the navigating officer is the pilot of the ship, although if he is not a navigation subspecialist, the duty of the pilotage devolves on the captain, who may either perform it himself or, at his discretion, depute any officer of the ship's complement to do so. No matter what the blind pilotage organization may be, the subspecialist navigating officer or the NO is always the pilot of the ship, and thus he should be the blind pilotage officer or the BPO, where no navigating subspecialist is born. The officer appointed for navigating should also be the blind pilotage officer in normal circumstances. But however, as responsibility for pilotage is clearly vested in the captain, he may wish to delegate the blind pilotage duty to some other officer. If so, the captain must also clearly set out in his standing orders the circumstances envisaged to ensure that this is absolutely clear who is responsible and when. Next slide, please. So, these orders must also take into account the organization for blind pilotage in various circumstances envisaged. The organization described below may have to be modified, but it must also be decided who is responsible for informing the captain of the collision risk with other ships. The NO or the BPO will be fully employed navigating the ship. Therefore, it is essential that the officer in charge of the operation room, who already has an anti-collision plot running, should be made responsible for advising the captain and OOW on this aspect of safety. The next is the conduct of blind pilotage. So the conduct of blind pilotage, the navigating officer should remain on the bridge in full visibility and conduct the blind pilotage from there. So it is essential to have another officer who is suitable by training and experience as a blind safety officer or the BSO in the operation room where he can monitor the blind pilotage and back up the navigating officer and the bridge. So the BSO will need to be in touch with the surface flat to assist with the identification of radar contacts. So the essence of this arrangement is that the members of the team do not change position if the visibility changes. The navigating officer conducts the pilotage in the bridge, whatever the weather or visibility. In good visibility, the BSO acts as useful check on the visual plan and builds up confidence in his team and the command. And in marginal visibility, the bridge team continues to make use of any visual information to supplement information from the radar. Next slide, please. Next, in nil visibility, the NO conducts a blind pilotage in the bridge radar display, monitored by the BSO. If reports from the NO and the BSO disagree, immediate action to stop the ship may be necessary until the position has been accurately determined, and the navigating officer should not move from the bridge to the operations room in order to conduct the pilotage from there, because this will cause delay and perhaps confusion, and can be particularly undesirable in marginal visibility, when a mixture of visual and blind techniques is required. Next photo.
So the conduct of blind pilotage. So there will maybe circumstances, particularly in large ships, where the navigating officer has already taken or wished to take the con and therefore charge the ship on the officer of the watch in order to conduct a pilotage or a blind pilotage situation has already arisen or rises. In such a situation, it may be undesirable for no to move to the bridge radar display as indicated above. The composition and duties of blind pilotage team must therefore have sufficient flexibility built in to cope with such circumstances. The no may continue to fund the ship from the Belarus taking full account of the navigational and collision avoidance information he is receiving from operation room. The bridge radar display, which should be manned by a competent officer such as NOS assistants and other sources. The bearing lattice team, lookouts, and etc. Despite being at the con, the no is still the pilot and the blind pilotage officer of the ship and retains full responsibility for this. Blind pilotage team and duties. So blind pilotage requires a high degree of organization and teamwork so that not only are the responsibilities of clearly defined, but also all relevant factors may be considered while assessing the ship position and her future movements. Suitable arrangement to achieve this are set out in Table 1. So this may have to be adjusted depending on the class of the ship, the personnel available above the comments. So place, operation room, The personnel is the blind safety officer, and the duty will as a check on the ship navigational safety. Next is the operation room. The assigned personnel is a blind safety officer assistant, and the duties is to identify the marked ships and reports with charted depths. Next room is the operation room again. The personnel is the anti-collision plot, suitably experienced officer or the most experienced officer. Next is the sonar control room. The sonar controller is the assigned here. It reports information as ordered. Planning and execution of line pilotage. So to ensure success, the ship must be accurately navigated along a prearranged track in comfortably unrestricted waters. This is the best done by constant fixing using radar in conjunction with our aids such as DECA and EchoSounder. So in narrow waters and during the final stages of an anchorage, the delays in fixing are unacceptable to the BPO. It is therefore necessary for anti-collision and navigation. So to work directly from the radar display using a prepared notebook, but it is necessary to pass radar information for fixing at regular intervals as a safety check and as an insurance against the radar failure. So the following principles may apply. The navigating officer should navigate or pilot the ship. Second is the captain should have easy access to the blind pilotage position and the no. The ship should be gone from the compass platform because it is only the bridge that the fuel of the ship can be retained. Fourth, the captain, blind safety officer, officers on watch, and the officer in charge of the anti-collision plot should all be carefully briefed before the passage by the NO, so that they are all entirely familiar with the visual or blind plan. Fifth is the navigational chart with the NO prepared visual or blind plan must be available on the bridge and in the operations room. So sixth, the whole pilotage team should be exercised as frequently as possible in clear weather in visual and blind techniques. So only in this way we can be very confident in the system we built up, which will allow runs of some complexity to be conducted safely in blind condition. So the PSO should be close up on a location of entering and leaving harbor and passages through narrow waters. When special sea duty men are close up, the BP team should be regarded as part of sea duty men.
The following principles apply. Number 8, there should be a good communication between the blind piloted position and the BSO and personnel manning navigational aids fitted elsewhere. Number 9, all members of the team should be encouraged to admit any doubts when they may have regarding the information acquired from the sensors. Blind pilotage planning. So first, normal planning considerations for selection of tracks apply. Blind and visual tracks should be the same to enable the transition from visual to blind or vice versa to be made at any time, and also to allow one plan to be used to cross-check the other. Number 2, the number of course alterations should be kept to a minimum to reduce the workload in redrawing the parallel and well-over lines. Number 3, always try to have two parallel index lines where possible, one on each side of the track. These provide a check on measurement, mark identification, and can reveal index or linearity errors. Number 4, objects to be used both for parallel index lines and for fixing must be carefully selected. They should be radar conspicuous and unchanged by varying heights of tide. Clearly mark on the chart the objects to be used for fixing and brief the assistant. Avoid a possible fixing by radar range and bearings on a single mark. The range scales to be used required careful consideration. Accuracy is greater at shorter ranges, but marks pass more quickly than at a distance, requiring more lines to be drawn. When operating on short-range scales, it is essential that the BPO frequently switches to longer ranges to keep aware of developing situations, changes of range scales, and parallel index marks should be pre-planned and marked in the notebook. The stage at which charts will be changed must also be carefully considered. Number 6, tidal streams and currents should be worked out and noted for calculation of courses to steer and for calculation of EP. This should be displayed on the chart and recorded in the notebook. Number 7, expected soundings, allowing for height of tide and calibration of echo sounder should be noted for each leg. The possibility of being early or late should also be borne in mind. Number 8, all hazards along the track should be boxed in by. Number 9, details of all lights and fog signals should be taken from Admiralty list of lights and chart and enter in the notebook. The chart, number 10, the chart should be drawn up using standard symbols to see in table 2. Blind pilotage chart work. In parallel index lines, to stay on track, the symbol must be a solid line. In clearing ridges, the symbol is broken line. In wheel over ranges, the symbol is dot. Next slide. The term dead range in figure 4 and 5 is used to describe the range of a mark ahead when anchoring in a chosen position. The term may also be used when measuring the progress of radar conspicuous object along a parallel line. As shown in figure 25, radar conspicuous objects such as buoys should be highlighted to enable the BPO to have a clear mental picture of what he expects to see on the display. Next. The notebook 11. The notebook should contain the full plan, neatly and legibly recorded in chronological order. Sketches of both chart and radar display in figure 23 can be of great assistance to the BPO in evaluating the picture. A suitable notebook layout supplementing figure 23 is shown in figure 24 as a guide to blind pilotage planning. Number 12, tracks plotted for entering and leaving harbor should not appear on the same chart simultaneously, otherwise confusion will arise. Number 13, clearing range should be simple, safe, and easily interpreted. Number 14, objects used for wheelover should be conspicuous, easily identifiable, and suitably located adjacent to the track. This illustration is preparation of the chart and displays for the blind pilotage. Blind pilotage execution to be reported by Paredes.
So, blind pilotage execution. First is to carry out a time check to synchronize clock and watches. So the second is on the radar display, keep one set of parallel index line drawn up ahead of those in use. Any more will clutter the display excessively, rub out lines as soon as they are finished with 3. So third is identify contacts early by range and bearing from charted object, and accurate EP is almost useful aid in identification. Fourth is to fix at frequent intervals and intermediately after a change of course DR EP ahead. A suitable fixing procedure is first is to BPO assistant standby fix in 1 minute. BPO Roger using point A, B, and C. BPO assistant writes this in notebook. Next slide, please. So in BPO assistant fix now, BPO marks the point on face of the display as BPO assistant notes the time. BPO then rages off the marks drawn on display and passes this to the BPO assistant. BPO assistant records the ranges, plots the fix, and generates fresh DR and EP. This procedure cuts the time take a fix and reduce the risk of a cocked hat due to ship movement. It may be quicker to interpolate from the range rings rather than to use the range strobe, although the latter will be more accurate. As you can see in the figure 4 in the left side, this is a layout of a navigating officer's notebook where you can see the course, remarks, and display to wheel over or WO miles and minimum depth in meters. So next slide, please. So the fifth one is to ship speed. One of the factors affecting the choice of a ship speed will be the rate at which the BPO and his assistants are capable of dealing with the radar information. So same as the other slide in figure 4, the layout of the navigating officer's notebook, you can see the course, remarks, and the distance of wheel over miles or WO and minimum depths in meters. Next slide, please. So in the sixth is to commentarily and conning advise maintain a steady, unhurried, and precise flow of information to the command, which is consist of the distance of track on track course to maintain or regain, distance and time to next upwheel over new course, and present new course clear of shipping, adjusted marks or hazards, expecting lights and sound signals, and expected depth and echo sounding. Next, please. And to commentarily and conning advice maintain steady and hurried and precise flow of information in command. The continuation is the minimum depths when fixing and result of fix EP to next alteration, maneuvering limits, example, 5 cables clear to starboard, 1 cable to port. If any doubt, say so, and if necessary, stop the ship. So next slide, please. Seventh is it must be appreciated that whatever the technique employed, a drift offline is likely to be detected less readily by radar than visual methods. And lastly is it is vital to pay attention to the echo sounder and the less deep depth expected the nearest land in usually the bottom. So next slide. So blind pilotage exercise. In the blind pilotage exercise, to improve the reality of BP exercises in clear weather, the following points should not be forgotten. Safe speed should be maintained, fix should be recorded and plot at the same frequency as for the actual blind pilotage. A full debrief should take place on completion of the practice. So next slide, please.
Blind anchorage. A blind anchorage should be planned in the same way as a visual anchorage, but remember to allow system to radar instead of system to standard when plotting the let-go position. As shown in figure 25, parallel index lines should be used to guide the ship to the anchorage position, and she must stay boxed in clearing ranges. Distances to run can be obtained by using a dead range on a suitable object ahead, or by measuring the progress of the radar conspicuous object along a parallel index line. Full details must be shown on the chart and in the notebook. Distances to run must be marked on the face of the display. Next slide. This is the figure 5, the blind anchorage execution. In part A is the chart, in the part B is the radar. Next. Blind anchorage. This can be backed up by the range strobe, but reliance on the strobe alone is dangerous because the reference is lost as soon as the strobe is required for any other measurement. In figure 5, the dead range of the point of land ahead when anchoring is 2.3 cables. The distance to run to the anchorage position may be obtained by subtracting the dead range from the actual range of the point. For example, if the range of the point is 7.3 cables, the distance to the anchorage is 7.3 to 2.3, minus 2.3 is equal to 5 cables. Next. Figure 2 also shows that dead range of the point of land on the starboard side when anchoring is 3 cables. On the radar display, this point of the land should move along the parallel index line drawn 2.5 cables to the starboard of the approach track. When the ship reaches the let-go position, the point of the land should have reached point A, 3 cables beyond the abeam position B. The distance AB equals the dead range, 3 cables. Next slide. Navigational records. When carrying out a blind pilotage passage, the navigating officer or BPO will be too busy to maintain a continuous written record. It is essential that such a record should be kept, and in comparatively unrestricted waters, it is normally sufficient for this record to be kept on the chart itself by plotting fixes and noting the positions and times of alterations of course and speed and other relevant data, in addition to the record in the navigational record book. This procedure involving thorough and methodical chart work is in fact no different from which should be practiced during any piloted passage in more restricted conditions. However, the navigating officer or BPO's running commentary to the captain should be recorded on tape if possible. For example, number 7 buoy fine on port bow, 8 cable ship 50 yards to port of track steer 136 to regain. In conjunction with the navigating officer or BPO's prepared notebook, the chart, the recorded fixes and courses and speed. This record should suffice for any subsequent analysis required. Horizontal displays. Where horizontal displays are available in operations room, the whole passage may be prepared in advance on a series of overlays. The BSO's assistant changing this at appropriate times. The drawback of this method is that all tracking and other additional marks made by the BSO are lost at each change. With most horizontal displays in use in the Royal Navy, the picture is not sufficiently precise for accurate blind pilotage and should not be used. That's all. Thank you.